Ever wondered what really happens when you light a candle and watch the flame flicker to life? Or when you fire up a stove to cook your favorite meal and a blue flame appears instantly? That's combustion, a rapid chemical reaction between a substance and oxygen, releasing both heat and light in the process. It's the science behind every flame you see. This powerful process is what powers everything from cozy campfires and roaring bonfires to the engines that move our cars and trucks. Combustion is just a scientific term for burning, when something reacts with oxygen and transforms, releasing energy in the form of heat and light. It's a transformation you can see and feel. For example, when you strike a match, friction creates enough heat to start the reaction, and the chemicals on the tip ignite with oxygen from the air. That tiny spark is all it takes to unleash energy. The same principle applies to your kitchen stove. A spark starts the gas burning, producing a steady, controlled flame for cooking your meals safely and efficiently. Combustion is a controlled chemical reaction we use every day, often without even thinking about it. It's essential for warmth, light, and preparing food. In simple terms, combustion is when a substance reacts rapidly with oxygen to produce heat and light. Combustible substances include paper, wood, petrol, and natural gas, materials that catch fire easily and fuel our daily lives. Non-combustible materials, like stone or glass, don't burn, no matter how much heat you apply. They simply don't react with oxygen in the same way. Understanding combustion is the first step to mastering fire science, which helps us use fire safely and wisely in our everyday lives. It's all about a substance, oxygen, and a bit of heat coming together to create energy. A fascinating process that's at the heart of so many things we do. To start a fire, you need 3 essential things: fuel, heat, and oxygen. These 3 elements must all be present and working together for a blaze to ignite and keep burning. This relationship is called the fire triangle. It's a simple but powerful way to understand how fire works. If you remove any one of these 3 sides, the fire will go out immediately, no matter how strong it was. Fuel is anything that can burn, like wood, gasoline, or natural gas. It's the material that actually catches fire and keeps it going. Fuel stores chemical energy, which is released as heat and light during combustion. Without fuel, there's nothing for the fire to consume. Next, let's talk about heat. Every type of fuel needs to reach a certain temperature, called its ignition point, before it will catch fire and start burning. That's why we use kindling or small twigs to start a campfire. They heat up and ignite much more easily than big logs. The heat source can be a spark from a lighter, friction from rubbing sticks, or even a lightning strike during a storm. Without enough heat, even the best fuel won't burn. The fire simply won't start, or will quickly die out. The third side of the triangle is oxygen, which makes up about 21% of the air we breathe. It's all around us, invisible but vital. Oxygen is the key partner in combustion, allowing the chemical reaction to keep going and the fire to burn brightly. Most fires need a steady, fresh supply of oxygen to keep burning hot and strong. Try covering a candle with a glass jar. The flame will slowly shrink and go out as the oxygen inside runs out. The fuel and heat are still present, but without oxygen, the process of combustion comes to a halt. That's also why blowing on a small flame can put it out. You're pushing the oxygen away, making it impossible for the fire to survive. The fire triangle explains both how to start fires and how to stop them. It's a fundamental concept in fire science and safety. Mastering the fire triangle is essential for understanding fire safety, whether you're camping, cooking, or just lighting a candle at home. Not all fires are the same. Combustion comes in different types. First, rapid combustion. This is what you see in gas stoves or burning paper. Quick, controlled, and producing heat and light. It needs an external spark to start. Next, spontaneous combustion. Some materials, like oily rags or hay, can heat up slowly and catch fire on their own if the heat can't escape. Finally, explosions. The most dramatic type, where combustion happens almost instantly, releasing massive energy, heat, and sound. Think firecrackers. Explosions create shock waves and can be very destructive. Each type follows the fire triangle, but behaves differently. Rapid combustion is useful for daily life. Spontaneous combustion is a hidden danger. Explosions require extreme caution. Fuels are materials that store energy and release it through combustion. We use them for electricity, transportation, cooking, and heating. A good fuel should be available, affordable, easy to store and transport, and have a high calorific value, meaning it releases lots of energy when burned. It should burn at a steady rate and not produce harmful substances or much residue. No fuel is perfect. Wood is cheap but smoky. Petrol is powerful but polluting. Scientists are always searching for cleaner, more efficient fuels. As we learn more, we can make smarter choices to balance our energy needs and environmental responsibility. The right fuel powers progress and protects our planet. Fuels exist in three main states: solid, liquid, and gas, each with its own unique properties and uses in our daily lives. Solid fuels like wood and coal are easy to store and often inexpensive, making them popular for heating and cooking in many places. However, they burn slowly, produce a lot of smoke and ash, and can contribute to air pollution if not used carefully. Liquid fuels, such as petrol, diesel, and kerosene, are energy-dense and ideal for vehicles and machinery. They burn cleaner than solid fuels, making them more suitable for engines, but they must be handled and stored with care due to their flammability and risk of spills. Spills of liquid fuels can be dangerous, harming the environment and sometimes causing fires or health hazards if not managed properly. Gaseous fuels, like natural gas, LPG, and biogas, are the cleanest options. They mix easily with air for efficient combustion, leave no ash behind, and are widely used for cooking and heating in modern homes. These fuels are easy to control and adjust, but they require special pressurized storage or pipelines to keep them safe and ready for use. Each type of fuel has its own advantages and disadvantages, so we choose the best one depending on the job or situation at hand. Solids are great for heating and open fires, liquids power our vehicles and machines, while gases provide clean, easily controlled flames for cooking and heating. Learning about different fuel types helps us make smarter choices and use energy more wisely in our homes and communities. Choosing the right state of fuel not only makes energy use safer and more efficient, but also helps us save money and protect our environment. The fuels we use impact everything from how we cook and travel to the air we breathe and the climate we share. That's why understanding fuel science is so important for our future. Always pick the right fuel for the right purpose, considering safety, efficiency, and environmental impact. In the end, it's all about matching the right fuel to the right need, making smart choices for ourselves and the planet. The calorific value tells us how much energy a fuel releases when burned. It's measured in kilojoules per kilogram, kJkg. Higher calorific value means more heat from less fuel. For example, LPG has a much higher calorific value than wood, so a small cylinder lasts longer than a big pile of logs. Rockets use fuels with extremely high calorific values for maximum thrust. Airplanes use high calorific fuels to travel farther on less weight. But calorific value isn't everything. We must also consider cost, availability, and pollution. A fuel might be powerful but too expensive or dirty for daily use. Understanding calorific value helps us compare fuels and make smart energy choices. It's about getting the most energy with the least waste. Look closely at a candle flame. It's not just one color. The flame has 3 zones: inner, middle, and outer. The inner zone, near the wick, is dark and coolest, full of unburnt wax vapor. The middle zone is bright yellow or orange, where incomplete combustion happens, and glowing carbon particles create the light. This is hotter than the inner zone, but not the hottest. The outer zone is faint blue and almost invisible. Here, there's plenty of oxygen, so combustion is complete and hottest. No soot is produced in this zone. Goldsmiths use the outer zone for its high temperature. Each zone tells us about the combustion process. The color and heat of a flame reveal what's happening inside. Understanding flame zones helps us use fire more effectively. It's science, you can see. Burning fuels gives us energy, but it also causes pollution. Fossil fuels like coal and diesel release harmful particles and gases. Incomplete combustion produces carbon monoxide, a deadly, invisible gas. Burning fuels also releases carbon dioxide, a greenhouse gas that drives climate change. Sulfur dioxide from coal and diesel causes acid rain. Fuel efficiency means getting more energy with less waste and pollution. Using cleaner fuels like CNG reduces harmful emissions. Renewable energy sources, solar, wind, hydro, produce power without combustion. Smarter fuel choices protect our health and the planet. Responsible energy use is everyone's job. Knowing how to control fire is crucial for safety. To put out a fire, remove one side of the fire triangle: fuel, heat, or oxygen. Water cools fires and removes heat, great for wood or paper, but never use it on electrical or oil fires. For electrical or oil fires, use a fire extinguisher. Carbon dioxide or dry powder types cut off oxygen and cool the flames. Foam extinguishers float on burning liquids to smother flames. If your clothes catch fire, remember, stop, drop, and roll. Don't run, drop to the ground, and roll to smother the flames. Every home should have smoke alarms and a fire extinguisher. Fire safety plans save lives. Respect fire's power and be prepared. Simple steps can prevent disaster. Firefighters use these principles every day. Stay alert, stay safe. Fire is useful when controlled.